Let's take a look at combinations of functions and composite functions. First thing we're going to talk about is domain. Now domain is all of your x values where your graph exists, and by default it's all real numbers. I can spell real. Let's try that again. All real numbers except ones that cause a denominator to equal 0, and ones that cause a negative number in a radical with an even index. Okay. Now this kind of grows as you go along. Like when we get the logs, we'll add a third one onto here and so forth. But for now, these are the only two we have. Now this first one, blah 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 denominator. That implies you have a fraction. Second one, blah 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 radical with an even index. That implies you have a radical. So if you don't have a fraction, you don't have a radical. Again, your domain is all real numbers at this point. So let's look at our first problem. We got f of x equals x squared minus 4x minus 7. And instructions are to find a domain. Well, we don't have any fractions, don't have any radicals, so our domain is negative infinity to positive infinity by default. Let's take a look at one with a fraction. We have f of x is equal to 2 over x squared minus 6x minus 27. Same instructions, find domain. Now if you have a fraction, and this is for finding a domain, first thing we're going to do is set the denominator equal to 0 and solve it. So set denominator equal to 0 and solve. Well, in this case I have x squared minus 6x minus 27 and set it equal to 0. This factors using the PSD method. So this is x minus 9 times x plus 3. Zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So we'll set x minus 9 equal to 0 and x plus 3 equals 0. Then we get 9 and we get negative 3. Now these are the numbers that cause us problems. For example, if I put 9 up or negative 3 up here, negative 3 squared is 9. Negative 6 times negative 3 is 18. 18 plus 9 gives us 27, and 27 minus 27 gives us 0. So these are the values we cannot have. So our second step is put a slash through the equals. So for our domain, x cannot equal to 9 and x cannot equal to negative 3. Now if you want to see how that's written in interval notation, we'd have negative infinity to negative 3, parentheses, union, begin parentheses, negative 3 to 9, in parentheses, union 9 to positive infinity. For purposes of my class, I'm happy with this right here. Let's take a look at this one. We got g of x is equal to 1 over x squared plus 9 plus 5 over x squared minus 9. Now if you have two fractions, well, it's still the same procedure. You want to set your denominator equal to 0 and solve. So I'll set the x squared plus 9 equal to 0 and the x squared minus 9 equal to 0. So we'll set both denominators equal to 0. Well, this is a perfect example of when to use a square root property, because we can very easily get the squared part by itself. So I take the 9 over to the right side, becomes a negative 9. Square root property says you drop off your squared and you put a plus or minus square root around the other side. But 3 times 3 gives us 9, and the negative gives us an I. Now, for purposes of finding a domain, you get i's, you can ignore that part. So we'll cross that out. Well, let's do the other one. Take the negative 9 to the right side, becomes a positive 9. Square root property, we drop our squared, put a plus or minus square root around the other side. And 3 times 3 gives you a 9, so square root of 9 becomes just 3. So, these are the values that cause us problems. X cannot equal to negative 3, and x cannot equal to positive 3. If you want to write an interval notation, it'd go from negative infinity to negative 3, union, negative 3 to positive 3, union, 3 to positive infinity. Yeah, let's take a look at one more fraction. So we got g of x is equal to 1 over 2 over x plus 1 minus 3. Well, same idea. If we have a fraction, you set your denominator equal to 0. But in this case, we have two denominators. We have an inside fraction here. This is called a complex fraction, specifically a complex rational expression. That's where you have x's, but a complex fraction. So we got a fraction inside here. Well, it's got its own denominator, x plus 1. So we need to set the x plus 1 equal to 0. And then looking at the outer fraction, all of this is our denominator. So we're going to set 2 over x plus 1 minus 3 equal to 0. Well, on this one, take the 1 over, becomes a negative 1. And that's our first x value. On this one, this is a rational equation. And we get rid of the fractions first, multiply everything by LCM of all our denominators. We only have one denominator, the x plus 1, so we're going to multiply everything times x plus 1. So multiply times our first fraction, multiply times a negative 3, and we'll multiply times a 0. Well, the x plus 1 is going to cancel here and leave us 2. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. 0 times anything is 0, so that's going to drop away. At any step, combine together numbers. 2 minus 3 gives us negative 1. We're solving for x, so I'm going to take the negative 1 to the right side and it becomes a positive 1. And then divide both sides by negative 3. And we end up with x is equal to negative 1/3. So we have x equals negative 1 and x equals negative 1/3. These are the values it cannot be. So x cannot equal negative 1 and x cannot equal to negative 1/3. If you want to write that in interval notation, the negative 1/3 is my smaller number. Wait a minute. Negative 1 is, sorry. So let's go from negative infinity to negative 1, then union, negative 1 to negative 1/3, then union, negative 1/3 to positive infinity. You'll see a pattern here pretty soon with the interval notation. Always starts at negative infinity, goes to our first smallest number, union, our first smallest number, comma, our next number, and then union, and then that number, and then to positive infinity. Everything always has parentheses on it. Again, I'm happy right here. Now, the negative one's pretty easy to see. Plug that in, gives you a 0 in this fraction. The negative 1/3 is not so easy to see. You'd have to do some manipulation, but that also would give you a 0 in the denominator. Let's take a look at a radical. Here we have g of x is equal to square root of 5x minus 25. Same instructions, find domain. Well, This time, this is a radical with an even index. Now your index is whatever number's in this little slot right here. If there is no number there, it's by default 2. So this is a radical with an even index. What we do is we set what is under the radical greater than or equal to 0 and solve. It can be greater than 0, that's positive. It can be equal to 0. It just can't be negative. So we'll set 5x minus 25 greater than or equal to 0. Now we're wanting to solve for x, so we'll take a negative 25 over to the right side, becomes a positive 25. Divide both sides by 5. And we end up with x is greater than or equal to 5. Now interval notation wise, that would be bracket 5 comma infinity. And I'm happy with that form, but again, you can do the other one if you wish. Now I've already saved these, so I'm going to go ahead and just start a new page. And let's look at the next problem. So we got h of x is equal to square root of x minus 5 plus square root of x plus 2. We got two radicals with even indexes. Well, we'll do the same thing. We'll set both of them greater than or equal to 0. Just like when we had two fractions, we worked with both denominators. Well, then we'll solve this. This gives us x is greater than or equal to 5, and this one gives us x is greater than or equal to negative 2. Well, let's think what this means, and I'll just work with integers because it's easier. X is greater than or equal to 5 would be what? 5, 6, 7, so on. X is greater than or equal to negative 2. That would be negative 2, negative 1, 0, and so on. Well, let's look at this 5 here. If I put 5 up here, 5 minus 5 is 0. Okay, that's okay. 5 plus 2 is 7, that's okay. If I put 6 in there, 6 minus 5 is 1, that's okay. 6 plus 2, that's 8, that's okay. Let me put negative 2 up here. Negative 2 minus 5 gives us a negative 7. We cannot have a negative number inside of our square root. So this one right here, actually, we cross off, and our answer is x is greater than or equal to 5. If I put an interval notation, that'll go 5 to positive infinity. Now the best way, if you have two radicals like this, is do some test cases like what I just did and check that out. I'd be tempted to say it's always your larger number that you keep, but depending upon if you divide by a negative number, you may flip these around, and it isn't set in stone. Well, next problem is going to ask us to do some operations on functions. So we're going to write this down. We've got f of x is equal to 3x squared minus 11x plus 6, and g of x is equal to x minus 3. And we want to find 4 things. I think the book actually specifically asks for 5 things. Asks for the domain too, but there's so many domain problems up above that, I figure you probably have that down. I don't like to just assign problems for busy work. If I feel like you know it, then I won't assign extra ones. Now we got f plus g, f minus g, f times g, and f divided by g. So let's find those. Now f plus g means we're going to add two functions together. So we'll put parentheses around each of the functions and put a plus between them. Now sometimes the parentheses are necessary, sometimes they're not. In this particular problem, they're not doing anything. So I'll combine together like terms. I got negative 11x plus x gives us negative 10x, and 6 minus 3 gives us 3. And that would be our problem. Well, let's look at f minus g. Again, we'll put parentheses around our functions. Then we'll put a minus between them. Well, the parentheses around our first function isn't doing anything, so I can drop it. But the negative out in front of the other parentheses, it's going to flip a sign of everything in the inside. So the x becomes negative, and the negative 3 becomes positive. Well, combine together like terms.
Negative 11x, negative x gives us negative 12x. And 6 plus 3 gives us 9. Excuse me. Well, let's take a look at f times g. Now again, I'm going to put parentheses around my functions. So I got 3x squared minus 11x plus 6. That's my f. And then times g, which is x minus 3. Well, this is multiplication. I'm going to take the x here, multiply it times each one of the terms on this side. Let me do that first. X times 3x squared gives me 3x to the third. X times negative 11x is negative 11x squared. X times 6 is 6x. And then we're going to take the second term over here, the negative 3, and we'll multiply it times all three terms over here. Well, negative 3 times 3x squared gives us negative 9x squared. Negative 3 times negative 11x is positive 33x. Negative 3 times 6 is negative 18. Then we want to combine together like terms. So I got 3x to the third. Negative 11x squared, negative 9x squared is negative 20x squared. 6x plus 33x gives us 39x. And then a minus 18. And that'd be our answer. And last one for this problem, let's look at division. So put parentheses around my functions. Put them in this form. There we go. Okay, now with division, about the only thing you can do here is factor the top, factor the bottom, see if something can cancel. This top part would factor using the key number. Um, 3x squared minus 9x. Oops, screwed up on my signs. Using the key number here. Okay, negative 9. Okay, that's right. This is just x minus 3. It doesn't factor. Well, after I factor the top part with using the key number, I notice that they have x minus 3's in common. So that's going to cancel. And our answer will be 3x minus 2. Grab a drink, then we'll look at this next one. Okay. We've got f of x is equal to 5 minus 2 over x. G of x is equal to 2 over x. Well, I want to find f plus g, so I want to put parentheses around my first function, 5 minus 2 over x, plus, and then parentheses around my second one, which will be 2 over x. Now these parentheses aren't doing anything, so I can drop them. And actually, negative 2 over x plus 2 over x, they have the same denominator, and if I add together the top parts, negative 2 plus 2, they give me a 0. So they cancel each other away. So this one works out really nice. Now for subtraction. Again, I'll put parentheses around both of them, and put a minus between them. Well, the first set of parentheses doesn't do anything. Second set of parentheses, though, that negative out in front flips the sign of 2 over x. So it becomes negative 2 over x. Now, negative 2 over x is negative 4 over x. Now, if we're going to add or subtract fractions, it's helpful if they're both fractions. So I can put the 5 over 1. Now we want to get a common denominator, and the easiest way to get a common denominator in this problem is multiply two denominators together. So 1 times x, and that gives us x. So we're going to rewrite each fraction with that new denominator. Now the 4 over x had that, but the first one, we multiplied the bottom part by x, so we have to multiply the top part by x. So it becomes 5x. Excuse me. We get 5x minus 4 over x. Now this is a mixed number form, and you could have done this very simple. Up here, it's 5 minus 4 over x.
If you ever have a negative out in front of your fraction, the negative has to go up on top. So it'd go up with a 4. What you do is you multiply whatever's out in front times your denominator. 5 times x is 5x, and add the negative 4, and that gives us our 5x minus 4. So you could very easily come down to that step. A lot of people don't see that though, so I usually show them that so they at least have one method to do it. Okay, multiplication. Well, again, I'll put parentheses around them, put them next to each other. And this is a distributive property. We're going to take the 2 over x times the 5 and times the negative 2 over x. 5 times 2 over x gives us 10 over x minus 2 over x times 2 over x gives us 4 over x squared. Well, we get a common denominator again, which would be x squared. That one already had an x squared, so we leave it alone. This first one, we multiply it by x, so we have to multiply the top part by x. So that ends up giving us 10x minus 4 over x squared. Now, last part of this, divide. So f divided by g. So we're going to take our 5 minus 2 over x, and we'll put it over 2 over x. Now this is again a complex fraction, complex rational expression. The easiest way to simplify a complex rational expression is to multiply everything by the LCM of all your inner denominators. When I say inner denominators, I'm talking about these fractions that are inside. Now here we have one, 2 over x, and here we have one, 2 over x. So they're both x, so our LCM would be x. So I'll multiply the 5 by x, multiply the negative 2 over x by x, and the 2 over x by x down here. Well, x times 5 is 5x minus, those x's cancel, those x's cancel. So we've got 5x minus 2 over 2. And those will be your answers. Time for the tablet to blow up. There we go. Okay. This next thing is composition of functions. Over here we got some, I don't need to tell you what these are. You can tell by looking at them. And over here, I don't need to tell you what those are. You can tell by looking at them. I swear my artwork gets better and better every year. And I don't need to tell you what that is. You can tell by looking at it. But just for those who aren't as artistic as I am, these little over here is our plankton plants. These are little fish, and these are big fish. Now I realize the last life science class I had was 26 years ago, and it was environmental life science, which was a what color is a leaf type class. I had biology in high school. That was the last real one I had. I took physics as my science instead of the life sciences. So what I'm telling you may not be 100% correct, but we'll pretend it is. Little fish eat plankton, and maybe I can come up with some kind of formula that ties how much plankton plants they eat. Maybe it's 5x minus 1, which means if I want 4 small fish, put 4 in here. 5 times 4 is 20, minus 1 is 19. I need 19 plankton plants to support those 4 small fish. Now maybe when big fish eat little fish, and maybe this is the equation for that. So if I want one big fish, I put 1 in for x. 20 times 1 is 20, plus 3 is 23. That means I need 23 small fish to support that one big fish. Well, maybe our question is, what is this function here? What ties big fish to plankton plants? Or, going the other direction, what's this right here? A lot of times in nature we've screwed this up, not trying to understand the balance that goes on, and it's had bad side effects. And one big famous case is the wolves of Yellowstone. Wolves are hideous animals. They kill the elk,
which isn't so bad, but I'm sure the elk don't think that. But they also would go into campsites, and you'd have vacationers leave their baby out unattended in a baby in a crib outside. Don't ask me why they do that, but some people aren't very smart. And then a wolf would come in and snatch the baby and take it, and they'd never see it alive. Well, you know, nobody wants to go to Yellowstone and see like dead elk all over the place, or slaughtered from wolves, or have a wolf snatch your child, or even just scare you by coming up on you. So they hunted off the wolves. Horrible animals. Well, the idiot tourists were happy. They could leave their babies out unattended. The elk were real happy. They weren't being slaughtered anymore by the wolves. So they bred and fed, until one bad winter came, and there wasn't enough food supplies around. And there were so many elk that they started dying of starvation. Dead elk all over Yellowstone. I went into forestry out of high school, and my instructor showed us picture after picture of dead elk. It was a slideshow, and an hour worth of dead elk. He could have been taking the same picture of one dead elk over and over. They all kind of look alike when they're dead, but it helped make the impact that us trying to play God per se isn't good. You know, we can't try to control nature. We can't wipe out this part of the species and not expect it to affect other parts. So they reintroduced wolves, and they also reintroduced or they allow limited hunting. So now things are more in balance. Here in Kansas, hunters are hideous people. They go out there and they slaughter Bambi and Bambi's family and grandparents and cousins. They go out there Uzis and take care of them. Horrible people. Until, this is in my case, I'm going down the road at 70 miles an hour and that deer jumps out in front of me. I'm sitting there cursing hunters at that point, wondering why they weren't out poaching the weekend before. Even if you're the biggest animal lover, you got to have that balance. You got to have something keeping them under control. If you don't, then you're going to find them starving to death. And I don't think any animal lover would like to see an animal starve to death. That's got to be a horrible way to go. If you're into agriculture, you're from a farming community, you know that deer can wreak havoc on crops. My dad used to have big gardens out in the country, and he'd plant peas, and they would come in during the night, be 2 or 3 rows of peas, and they would go down and they'd clean out those entire rows. They loved it when it first came up. It was kind of fresh and tender, and oh, they loved that. My dad would put a radio down at the end of the garden to keep the deer away, and that worked pretty good. Didn't keep the raccoons away. They actually came in. I think they probably liked the music. They'd sit there and they'd eat on the corn at night. So, anyway, composition of functions is what this is about. So let's take a look at a problem. Now that you know the general idea where it's used at. Okay, so we got f of x is equal to 9x minus 2, and g of x is equal to 5x minus 1. And there's 3 parts here. It says find this fog-looking thing. What this is not fog. This is a composition of f and g. That's how you read that. For people that miss this lecture, they usually try to multiply these together. And it's just like, no, that's not multiplication. This is a composition symbol. Now, this is very easy. We rewrite that as f of g. And how I remember it is f is first here, so f is first here. G is second here, so g is second here. Now, this is like evaluating a function. So if you think about how you evaluated a function, you went through and everywhere you had an x, you put in parentheses. So we're going to take our f of x, which is 9x minus 2, and everywhere I have an x, I'll put in parentheses. Now, if you remember evaluating functions, whatever is inside the parentheses here is automatically what's going to go in there. So we're going to put g in there. But g is equal to 5x minus 1. So this can become 9 times 5x minus 1 minus 2. We replace the g with 5x minus 1. And then simplify. 9 times 5 is 45x. 9 times negative 1 is negative 9 minus 2, which gives us 45x minus 11. Now, second thing they're asking for is a composition of G and F. It looks like Goff. Again, it's not. That's the composition symbol. Well, we plug that into our function, G of F. And again, G is first here, G is first here, F is second, F is second. Now, remember, evaluating functions, we go through our G of X, and everywhere we have an X, we'll put in parentheses. Now, whatever is inside the parentheses here is what we automatically put in right here. So we'll put F there. But F is equal to 9x minus 2. So this becomes 5 times 9x minus 2 minus 1. 5 times 9x is 45x. 5 times negative 2 is negative 10 minus 1, which gives us 45x minus 11. And that's our answer. Now C says, find this weird looking thing. Now how you interpret this, this says first find a composition of F and G, and after you do that, plug 2 in for X. So that's how you interpret this. Well, we found a composition of F and G, that's in part A, and it's 45x minus 11. So we're going to take our 45x minus 11, and we're going to plug in our 2. So put 2 in for the x. 45 times 2 is 90. 90 minus 11 is 79, I think. And that'll be your answer. Let's look at another composition. And let me start a new page, just to make sure I have enough room. Got f of x is equal to 2x minus 1. And g of x is equal to 3x squared minus 5x plus 2. Okay, first thing we want to find is the composition of f and g. Well, that's f of g. And again, what we do is we go through, and everywhere we have an x, we'll take a look at f of x. Everywhere we have an x, we'll put in parentheses. That. Now, whatever's inside the parentheses here is what we're going to put in down here. So we're going to plug g in there, but g is equal to this. So we're going to plug in 3x squared minus 5x plus 2. That's kind of small. Let me try that again. Okay, there we go. So we got 2 times x minus 1. And again, whatever's in there is what we put in right here. But g is equal to 3x squared minus 5x plus 2. Well, 2 times 3x squared gives us 6x squared. 2 times negative 5x gives us negative 10x. 2 times 2 is 4. Minus 1. So that gives us 6x squared minus 10x plus 3. Now B. We want to find a composition of G and F, which is G of F. So again, we're going to take our G of X, and everywhere we have an X, we'll put in parentheses. Now everything else remains exactly the same. The 3 out in front, the squared, the minus 5, the plus 2. I just replace the x's with parentheses. Now whatever's inside this parentheses is what we're going to plug in right here, which is f, but f is 2x minus 1. So we'll put 2x minus 1 in there. Now 2x minus 1 squared, we have to rewrite as 2x minus 1 times 2x minus 1. Here we use a distributive property. Negative 5 times 2x gives us negative 10x. Negative 5 times negative 1 is a positive 5. Plus 2. 2x times 2x gives us 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x. And negative 1 times negative 1 is a positive 1. Minus 10x. 5 plus 2 gives us 7. And that gives us 3 times 4x squared. Combine together like terms. Negative 2x and negative 2x is negative 4x. Plus 1. Minus 10x plus 7. Now multiply the 3 through using the distributive property. 3 times 4 gives us 12x squared. 3 times negative 4x gives us negative 12x. And 3 times 1 is 3. Minus 10x plus 7. Combine together like terms. Negative 12x, that is negative, isn't it? Yeah. Negative 12x minus 10x is negative 22x. 3 plus 7 is 10. And that would be our answer. Okay, part C. Want to find composition of f and g first, and then plug in 2. Well, we found that right here. That's a 6x squared minus 10x plus 3. That's composition of f and g. So now we want to plug 2 in for x. So everywhere there's an x, I'll put in parentheses and put 2 in. Okay, 2 squared is 4, so we got 6 times 4. Negative 10 times 2 is negative 20 plus 3. 6 times 4 is 24 minus 20 plus 3. 24 minus 20 is 4. 4 plus 3 gives us 7. Assuming I didn't make a math error anywhere. Yeah, I believe that's the end of that section. So let me go ahead and save off this recording.